Hey, what's going on, guys? Let's do this problem right here. The question is asking an escalator in a shopping center is designed to move 50 people, 75 kilogram each, at a constant speed of 0.6 meter per second at 45-degree slope. Determine the power input needed to drive this escalator, and what would your answer be if the elevator velocity were to be doubled? So let's see what happens when it's in this velocity 0.6, right? So 0.6, the first thing is we have to calculate the total mass. So total mass is going to be so we have 50 people right here. Each people weigh 75 kilograms, so we just have to multiply 50 by 75 to calculate the total mass, and that's going to give us 3750 kilogram, right? So that's what we get. And also here we have 0.6 meter per second, 45-degree slope. So we have to find the vertical component because we are dealing with the energy, and this is going to have potential energy, right? So we have to find the vertical component of this speed. To find that, we can use sine 45. So let's say this is vertical component is equal to 0.6 sine 45. So that's going to give us 0.4242 meter per second. So now we have calculated this velocity and the mass, and let's see how we can apply this one to find the power, right? So power is the main question. So the equation we are going to use is E in, energy in, it's an energy balance equation. Energy in minus energy out is going to be the complete energy of the system. So that's going to be dE over dt of the system, right? D over dt of the system. So this is the one we are going to use. So we know that there's no energy out, so we can put it as 0. So E in minus 0, that's going to be d over dt. And this system is in potential energy, so we can say it's a potential energy over delta t. And this is also, since we are talking about dt, we have to put dot right here. It's per unit time, right? So per unit time, so this is going to be potential energy over delta t. So E in is going to be work in. That's what we are going to find. Work in, and it's going to be in terms of per unit time. So that's going to be the watts. That's going to be the power, because we know that joule per second is power. So when we find this one, it's going to be joule per second, right? And we know that potential energy is going to be mgh. So we can say mg elevation, that's going to be delta c divided by delta t. And also we know that this thing delta z over delta t, that is equal to velocity, right? So we have the velocity already we found out right here, so we can substitute that one to find this answer. So let's write this one in terms of velocity. So we can write this one as mg vt, right? V vertical, V vertical. So that's going to give us the work, that the power input needed, right? So here we have the total mass, that is 3750 kilogram times this g is acceleration due to gravity, that is 9.81 meter per second square, multiplied by this velocity, that is 0.4242 meter per second. 0.4242 meter per second. And if you calculate this one, you will get, so this is going to give us 15.6 kilojoule per second, and that is equal to kilowatts, right? Joule per second is watts, so this is equal to 15.6 kilowatts. And that's the question. That's the first question, right? The first question is asking determine the minimum power input needed to, so minimum power input, that's what we calculated right here. And the second question is asking what would your answer be if the escalator velocity were to be doubled. So we are going to use the same equation. So here we are going to have new Win, that is equal to mg b vertical component of b. So here we are going to have, instead of using 0.6, we are going to use 1.2 because they are saying the velocity were doubled, right? So we are going to double this velocity, that's going to be 1.2 meter per second. So here we are going to have the same mass, that's going to be 3,750 kilogram multiplied by acceleration due to gravity, that is 9.81 meter per second square, multiplied by the new velocity, but we have to calculate this one in terms of vertical component, so we have to use the sine theta again, sine 45. So this is going to be 1.2 meter per second times sine 45, right? And if you plug all this value in calculator, you will get 31.22 kilowatts. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching.